Hello all, welcome to this video. Here you will learn about Region Proposal Network, in short, called RPN. After watching this video, you will be able to understand basic term of RPN and understand working of RPN in easy way. Let's learn about some of the basic term of RPN. Region proposals are the region surrounded by the bounding boxes where the object lies. Anchor boxes are the bounding boxes of different scale and ratio that can fit the object of different shape and size. If K is the number of anchor boxes and W is width of the feature map and H is height of the feature map, then for the whole feature map, the number of anchors boxes is W times H times K. Now let's learn how RPN works. RPN is a fully convolutional network that generates region proposals with various scales and aspect ratios. It works as a attention layer to focus on that anchor boxes having object inside them. Region proposals are generated by sliding a 1x1 filter over the output of the last convolutional layer that we get from pre-trained model. We use pre-trained model like AlexNet that gives total 256 feature maps of size 3x3, and for VGG16 this gives total 512 feature maps of size 3x3. We get total 36 feature maps using 1x1 filter by sliding over the total 256 of 512 feature maps of size 3x3, and each feature map has 9 values. Then for 36 feature maps, total values will be 36 times 9 equals 324, and we required 4 values from total 324 values to create anchor box. So total anchor boxes will be 324 divided by 4 equal to 81. That means we created 9 anchor boxes at each location or at each pixel on the feature map of size 3x3. According to this formula, W times H times K, that gives 3 times 3 times 9 equal to 81 anchor boxes. Same we do for objectness score. We get 18 feature maps using 1x1 filter by sliding over the total 256 of 512 feature maps of size 3x3, and each feature map has 9 values. Then for 18 feature maps, total values will be 18 times 9 equals 162, and we need 2 values from it to create objectness score of anchor box having object or not. So according to that, it will give objectness score of 162 divided by 2 equal to 81 anchor boxes that we created. Here you can visualize all the concepts that were explained in the previous slide. Here using AlexNet we created 9 anchor boxes at each location or at each pixel on the feature map of size 3x3, and as shown in the image, for the center location or the center pixel we created K anchor boxes, that is 9 anchor boxes. After creating 9 anchor boxes at each location or at each pixel of the feature map, we have to draw on the original input image, then remove unwanted bounding boxes or anchor boxes on the basis of the objectness score and on the basis of the non-max suppression. Let's learn ROI projection. Here ROI is region proposal, then we need to project them onto the feature map by projecting the region proposal with respect to the subsampling ratio. The subsampling ratio is defined as the ratio of size of the feature map to the size of the original input image. For example, input image size is 18 times 18, feature map size is 3 times 3, then subsampling ratio is 3 divided by 18 equal to 1 by 6. With a subsampling ratio here 1 by 16, we divide the size of the input image, center of the bounding box, as well as the width and height of the bounding box. In this way we project them onto the feature map by projecting the region proposal with respect to the subsampling ratio as shown in the image. Let's learn ROI pooling now. ROI pooling is used to convert projected region proposals given on the feature map into a fixed size region proposal for fully connected layer. Fully connected network accept fixed size region proposals. For this we divide the height and width of the region proposal, i.e. 5 by 2 cross 4 by 2 equal to 2.5 cross 2 point, and then rounding them gives 2 cross 2 and 3 cross 2. Then applied max pooling on that 2x2 and 3x2 divided region to get 2x2 fixed size region proposal. Now let's learn how to train RPN. This network learns to adjust the anchor box by predicting how far anchor center are from the ground truth center by adjusting center coordinates and adjusting the width and height of the anchor box as shown in the image. Same network also learned to predict objectness score. Here used softmax function to get objectness score having object or not inside the anchor box and used cross entropy loss function. And finally get brief introduction of fully connected network, that is the last network after region proposal network. The fixed size region proposal from RPN passes to the fully connected network, which takes the proposals and evaluates classes B box. These two networks have to train a bit differently. It classifies the object under region proposal belongs to which class and predicts bounding box again to refines the bounding box B box. In this video, you learned basic term of RPN, how RPN works, brief introduction of fully connected network.